Hello and welcome to the second in the Women in TechWorks webinar series. The Women in TechWorks initiative champions women and companies shaping the future of technology, and it will be officially launched at the 2025 IoT Security Foundation and TechWorks AI Conference, which takes place on Thursday, the 30th of October at London's IET. However, ahead of the official launch, we wanted to get going with these webinars, which is why today I have the pleasure of being joined by Catriona Wright, who is the co-founder of Chipletti. Catriona's presentation is entitled The Hidden Hero of AI, Why SRAM Matters. If you're watching this broadcast live and you have any questions, comments, or observations on what you're about to hear, then please put them in Zoom chat and I'll put them to Catriona during the Q&A section of today's broadcast shortly. But that's enough from me. We're going to cross over to Cambridge. Catriona of Chipletti, the floor is yours.
Brilliant. Thanks, Chris. So as Chris said, I'm Catriona Wright, a co-founder of Chipletti. And today I want to talk about the hidden hero of AI, which is memory, and why it's becoming the real performance bottleneck in artificial intelligence hardware. At Chipletti, we're working on a new way to make memory faster, more efficient, and more accessible to help new AI compute companies compete with giants like NVIDIA. Before I get into the details, let me give you some background about myself. So I went to school in Scotland. At school, I liked maths and physics, but I had absolutely no clue what I wanted to do with that. And it was my mum who suggested that I try out engineering at university. So I went to Edinburgh University and I started on a general engineering course, but in the second year switched over to doing electrical and electronic. That kind of pushed my buttons more. I started on a bachelor's course and had no clue what I wanted to do after university. So when the opportunity to do a master's came along, I jumped at it. I was really lucky and I managed to get sponsored for the project during the course by a company called Nortel Networks based down in Essex. And when I graduated, I went there for my first job as a digital ASIC designer. I couldn't have asked for a better first job. Nortel was fantastic. It was a massive company. They had a great graduate scheme program, lots of people there, lots of social life. It was a fantastic way of getting into the industry. Unfortunately, it was also my first redundancy, which was quite a shocker when you're, I feel like, still a new graduate. So after Nortel, I went on to a company called TTPcon, and I did IP there. After a while, I realized that I quite liked the idea of being a project manager. So I asked them if I could, one, try out project management within the company, but two, if I could do an MBA, because I wanted to improve my skills in that area. Unfortunately, they said that if I was sponsored by them to do an MBA, then I would leave. So I did leave without the MBA, and I went to a company called CamSemi, who were much more supportive. I changed my role. I went there initially as a digital designer, but they were a very small startup. And as we grew, they needed a program manager. So I moved into that role and they sponsored me to do an MBA with the Open University. I was there for about 8 years altogether. Loved it. Great job. Then I took a career break to have my daughter. That's me with my little Amelia. When I came back to work, I went to a company called DisplayLink, which is here in Cambridge. And worked there for a couple of years before I faced another redundancy. This is not the industry I was expecting, but this is how it goes. After that, I went to work for a company called Cambridge Touch Technologies. It was okay there, but it wasn't really my dream job. So I moved to another job in Cambridge with a company called Riverlane, who are a quantum startup scale-up. They're doing quantum error correction and making decoders for quantum computers. It was a great job, but towards the end of last year, I began to get itchy feet. And I happened to speak to one of the guys that I was working with who had come up with an idea. And this guy is called Kosa Johar. And together we started Chipletti at the beginning of this year. So that's how I got to where I am. But why am I here talking to you today as part of Women in the TechWorks webinar series? There aren't enough women in engineering industry, as is my opinion. And I think that there are two main challenges to overcome. The first is getting more women to consider engineering as a career. Stats have improved slightly, although not much better from when I was at university, but we can do better than this. We need to focus on schools and things like initiatives like code clubs, which Raspberry Pi promote, and anything else that can help children connect with what jobs in engineering are possible so that they can get excited about how creative they are. But the second thing is retention. There's a horrible stat that says women leave engineering at the average age of 43 compared to near a retirement age 60 for men. And that's just not right. With these women leaving, we lose talent, we lose leadership and experience, and the industry desperately needs those things. I'm hoping that by helping to promote women in TechWorks, we can address these challenges, increase the number of women who start in engineering, but also encourage them to stay. But why do we need women in tech? It's not just a moral issue when we're talking about diversity. It's about better problem solving. A lot of women naturally have great skills that are suited to engineer. But I'm talking beyond the ability to learn about technical work. Some of them are shown here. Collaboration and leadership are two that I think are absolutely key to engineering. I believe that it's really important for women to stay curious, be resilient, and to build a great network to give themselves the support needed to enjoy a fulfilling career within engineering. And more women in the industry makes a stronger network for all of us. But most importantly, I believe we need to work on something that really matters to us. We need different perspectives to overcome complex challenges. And those are challenges like we're faced with AI and semiconductors. And that's what my talk is about today, tackling a big complex problem from a new angle. Artificial intelligence is everywhere and it's growing. Everyone's talking about AI. How useful is it going to be? Will it take all our jobs? Will it take over the planet? Will we be able to support the power requirements it needs? To make it work, we need a lot of compute to handle data and bigger models, which means we are seeing exponential growth in compute demand across data centers. But this leads to enormous power consumption. Let's look at the AI hardware to understand this better. At a high level, AI needs a processor and memory. Simplistically, the processor does the maths while the memory feeds it data. If the memory can't keep up, the compute stalls. Performance depends on both working together. AI is changing everything. There are so many new applications coming online daily, and demand for them is growing. Users like us want faster, more accurate results. But AI isn't just about compute. It's about moving data efficiently. AI performance is limited not just by how fast we can calculate, but how fast we can move the data. There are many different computer architectures involving CPUs, GPUs, LPUs, even NPUs now, and all different sorts of memory. Each combination suits a different kind of workload. This is a nice animation, if I can make it play. There we go, from Grok. And it shows two different architectures doing the same job, but one being much faster than the other. Each architecture is trying to maximize performance per watt, per millimeter squared, per dollar. When we talk about performance, we could quote TOPS, theoretical operations per second, but it's not what users experience. Tokens per second is closer to what we should be thinking about, but it's not the whole story. But when we're thinking about the metric, we need to understand what part memory plays, and it's a huge part. Processors are faster than ever. In most AI systems, processors spend more time waiting for data than computing. That's called the memory wall. Processor speeds have increased dramatically, but memory access hasn't kept up. This creates a bottleneck. So even the fastest chips are limited by how quickly they can get their data. To overcome this wall, memory bandwidth and capacity needs to scale efficiently. Latency needs to be considered and would ideally be low, similar to local CPU memory. And we need to be able to scale to address future demands. Let's look more closely at the memory. This memory hierarchy pyramid shows some of the different types of memory available. We're going to focus on the middle two rows. Towards the top, we have SRAM, which has smaller capacity but fast access. Then below that, we have DRAM and HBM, which have larger capacities but are slower due to high latencies. Each step down the hierarchy trades speed for capacity, power, and cost. You can see the difference in capacity and latency down the right-hand side of my slide. AI efficiency depends on balancing the right types of memory. No one type wins. It's all about trade-offs between speed, capacity, and power. Let's take a look at HBM first. HBM, or high bandwidth memory, is stacked DRAM that delivers enormous bandwidth. You can see in my slide here the stacked DRAM, which is then placed onto the interposer with the compute. And then the compute die pulls data from the HBM through the interposer. Although HBM's capacity is smaller than DRAM, a single stack might hold only 16 to 48 gig. The much wider data bus gives it over 10 times the bandwidth. That's why it's perfect for training large AI models, where throughput and capacity dominate. But it's an expensive and power-hungry solution. Think of all the data movement going on and off chip through that interposer. Using HBM is NVIDIA's approach, but does one size fit all, as they would like us to believe? Training has had a huge amount of focus until recently, but now more people are looking at inference and the compute requirements for inference. Training and inference have completely different definitions of performance. Training is about throughput. How fast can you train a model? And here we're talking hours, days, or even weeks. So latency is less important. Inference is all about latency, that time to first token, which is measured in milliseconds or seconds. Training needs huge capacity, whereas inference needs deterministic low latency access. That difference is driving completely different compute and memory architecture to be developed. We've looked at HBM for training, so now let's consider how SRAM can help inference. It's a fast and deterministic memory, which makes it ideal for inference workloads. It's easy to integrate with logic, and every process node has an SRAM compiler, which can be configured into any shape or size. It's been used along with logic designs for many years, so its capabilities are well understood by designers. Could it be the unsung hero that bridges the memory gap? But there's a catch. The capacity is limited, being on chip. Here we hit a problem. SRAM has stopped obeying Moore's law below 5 nanometer process node. Its scaling has significantly slowed down, as you can see from this plot on the left-hand side. At advanced nodes, SRAM can easily occupy over 50% of the processor die area, as the layout on the right is showing you. We can't just keep adding more. It's too large and too costly. We need a new way to add memory capacity. So let's have a look at our options. We can increase the die area, but we'll soon hit the reticle limit. That's the maximum size a die can fit on a wafer. Also, the larger the die, the more yield issues it's likely to have. We could move to a more advanced process node, but remember that SRAM scaling has significantly slowed on nodes below 5 nanometers. So we'd end up paying a huge amount more for a slight increase in capacity due to the cost of the advanced node wafers. Going 2.5D would be similar to the HBM model, but then we lose the low latency advantage of SRAM, as data would have to travel through the interposer. We need to unlock more SRAM capacity without significantly affecting the low latency, deterministic, tightly coupled characteristics. Chipletti aims to achieve this by going 3D. 3D stacking isn't a cheap option, but we believe there's a sweet spot where the performance and efficiency gains outweigh the added complexity and cost. And that's the space that we're going to be targeting. At Chipletti, our solution is modular 3D SRAM chiplets. We're taking the SRAM out of the compute, putting it into a separate chiplet, and stacking it directly on top using hybrid bonding. This will unlock more memory, but still keep it close to the compute, improving performance. And because it's modular, designers can scale for different workloads and different applications. Think of it as building memory like Lego. Stack what you need. Chipletti will provide the interconnect IP to abstract away the complexities of the 3D integration, making designing easier. This also means there's no upfront commitment to how much memory is required. You can add what you need later in the design flow. By selling the same chiplets to multiple customers, we will amortize the NRE cost of development, which means our customers will be able to access 3D SRAM integration at a lower cost. Here's what that means in practice. By moving SRAM off the compute chip and stacking it vertically, we reduce data movement and power loss. Each compute chip can work harder, so fewer chips are required for the same workload. The system needs fewer modules and fewer long interconnects to deliver the same model throughput. This gives faster, cooler, and more efficient inference. From this example, you can see that we could save between 4 and 10 modules or optical cables for the same model. And that's saving a significant amount of power as well as increasing performance. Currently, we're working on our technology, but we're about to enter our next phase. We're looking for collaboration opportunities. Our aim is to raise a seed round early next year so that we can grow our team and make our first silicon demonstrator in collaboration with an early partner. Our focus is on working with new AI compute companies that want to differentiate their hardware and compete at NVIDIA scale. Then beyond that, we want to validate stacking multiple SRAM to expand capacity, working with our ecosystem partners from foundries to OSATs and IP vendors. Our roadmap is ambitious, but achievable. We only started in February this year, but we've made great progress through the ChipStart UK program, which is funded by DCIT and managed by Silicon Catalyst. Thanks to their in-kind partners, we're well on our way to demonstrating our technology in silicon. Next year, we aim to work on a full prototype integration. We're building momentum, and we're looking for partners who share our ambition to reshape AI hardware. Chipletti was founded by Costello and myself. Between us, we bring over 40 years of semiconductor experience, spanning design, prototyping, and product delivery. Our vision is to make high-performance memory integration accessible to the next generation of AI chip companies, and later on to other markets too. Thank you for listening. I hope this gave you a sense of why SRAM is the hidden hero of AI hardware and why solving these challenges can help create a more competitive and innovative AI ecosystem. I'd be happy to take any questions.
Brilliant, Catriona. Thank you very much indeed. If I could get you to stop sharing your slides, and then what I'll do is fiddle around a little bit so that we are both on the screen. There we go. Thank you very much. Right, let's get the Q&A section underway, and I'll start it off. What are the main challenges that you face?
So we've got two big ones. The first is thermals, and the second is logistics. So on the thermal side, high computing switching creates hotspots, and we need to mitigate that when we're building our 3D stack. But that's an engineering problem, not a showstopper. Separating SRAM from the compute die actually gives us more area for routing and for power balancing, which helps manage the heat. So although we know it's going to be a challenge, we're confident we can find a solution. And then on the logistical side, the ecosystem is not yet set up for stacking multiple dies from multiple foundries. And that's where we want to get to. So we're working with customers to create demand from the foundries so that they understand that this is the way they need to go, and help build a more open multi-foundry 3D integration ecosystem. So they're hard problems, but they're exactly the kind of problems that we enjoy solving.
Okay. What performance improvements do you expect to see?
It's a hard question to answer because it's very architecture dependent. And that's why we're looking for partners to help us validate our models. Conceptually, by having more SRAM close to the compute, we should be able to reduce data movement and power loss. So in the example I showed earlier, that could mean needing 4 to 10 times fewer modules for the same inference workload, with significant latency and power savings. The exact numbers will vary depending on the chip design, but the direction of the improvement is clear. We aren't just saving a few percent, we're talking orders of magnitude. In fact, the kind that could redefine the efficiency of AI.
Okay, you said that's quite a hard question to answer. We ain't here to do easy questions, are we? Laura on Zoom chat says, really interesting talk, thank you. Can I ask about something you mentioned at the start of the talk? Women leaving engineering at the age of 43. Why do you think this is, and what do you think could be changed in the industry to try and change this number? That's from Laura.
Thanks, Laura. I don't know I'm the best person to answer this question because I'm still here. And there has been research that's been done on it, but I don't know that research inside out. I just see the horrific statistics. I was exceptionally lucky in my university life and in my career. Although there was, when I was at university, we were 10% women, 1 in 10. So I actually found that helped because I was positively discriminated. I was remembered because I was a woman. So that was useful at university. And then when I went to my first job, Nortel, it was a great job. And one of the reasons was I had a female mentor. So I never felt different, I suppose. I didn't feel like I stood out because I was a woman. And I would love other women coming into the career, into engineering, to have the same experience as me. And I'm frustrated that they don't, I suppose. So yes, sorry, I don't know the ins and outs of why everybody leaves, but I would love to be able to provide or help give them a support system through a network of mentors, that kind of thing, to help them realize how important it is for them to stay and be productive in this industry.
And these are the sorts of issues that Women in TechWorks has been set up to address.
Absolutely.
So thank you very much for your question and for raising that point. It was Laura. Thank you. Okay. Keith on Zoom chat asks, well, he says, thanks for a great talk, Catriona. I completely agree on the need for more girls entering STEM courses. On Chipletti, is there not a benefit to deploying your tech in learning as well as inference? I'm thinking especially from a PowerPoint of view. Would really appreciate your perspective. Thanks. And that's from Keith.
Interesting. I'm not quite sure what you mean by that, but I mean, our tech can be applied anywhere that you need to expand memory, but keeping low latency. So AI inference, AI is the buzzword of the moment. It's a big market. It's also a market that is willing to take risks. And this is a new business, so it is risky. So that's why we're targeting it as our beachhead market, if you want. But there are so many other markets that could equally take this on. I would suggest that some of the other markets would want to wait until this becomes more of a mainstream technology so that it's cheaper and less risky. But there's absolutely nothing stopping us later on, further down the line, addressing those.
Okay, thanks for that question, Keith. Aren't there companies already doing stacked SRAM chiplets?
So AMD has demonstrated a stacked cache on their CPUs in their Ryzen product, but they're a vertically integrated company. So their technology isn't shared with anybody else outside of their own products. So for smaller and newer AI compute companies and other markets that we were talking about, developing an extra die in-house is extremely expensive. Our goal is to make this kind of technology accessible to everyone. So to help the next generation of AI hardware companies to compete with the big players like NVIDIA. But as I already mentioned, there's opportunities beyond AI too. So networking, automotive, anywhere that low latency memory matters.
Okay, thank you. As I mentioned at the start of the broadcast, Women in TechWorks is going to be officially launched at a conference in London on Thursday, the 30th of October. It's the IoT Security Foundation and TechWorks AI conference. Why is Women in TechWorks needed, Catriona? And what are the specifics that you would want to see it address? What would you like to see from it?
Yeah, so I mean, it's all about that retention question for me when we're talking about women already in tech. It's providing that mentoring, providing support system, helping women to network so that they can understand what job opportunities are out there. Yeah, it's a really good thing to be doing.
All right. If you're watching this broadcast live, I've put the link for the IoTSF and TechWorks AI conference in Zoom chat. So just click on that. Make sure it opens in a new tab before we disappear, because once this broadcast ends, Zoom takes everything with it. So open it up in a new tab, and if you would like to go for the launch of Women in TechWorks, your presence would be very much appreciated there. And we hope to see as many of you as possible at the launch of Women in TechWorks a bit later on this month. But in the meantime, the Women in TechWorks series continues with Suzanne Costello, and that will be on Tuesday, the 25th of November at 1 p.m. So watch this space, and we'll put the promotional material out there so you can register for that. But in the meantime, thank you very much to Chipletti co-founder Catriona Wright for joining us today. That was a fantastic presentation. And of course, this will be recorded if you would like to sort of go back and watch it again, so that you can maybe take screenshots of the slides or whatever. But there'll be more coming down the pike from Women in TechWorks. This webinar series is just the start. There's going to be a whole bunch of activity in 2026. So like I say, watch this space. Thank you very much for watching today, and we will see you next time for another Women in TechWorks webinar. Bye for now.